More examples on gas. Question number 1. A fixed mass of gas at constant volume is cooled from temperature 30 degrees Celsius to a temperature T, such that its pressure is half. That means P1 changed to P2, where P2 equal to P1 over 2. By applying the equations, P1 over T1 equal to P2 over T2, we have P1 over 30 plus 273 equal to P1 over 2 over T. Therefore, T equal to 151.5 Kelvin, or negative 121.5 degrees Celsius. Question number 2. The air bubbles rise from the bottom of the lake to the water surface at constant temperature. Its radius increased from R to 2R. Find the percentage change of air pressure inside the bubble. Since the temperature is constant, we should use the equation P1 V1 equal to P2 V2, and because the volume of a sphere is proportional to the cube of its radius, therefore V2 over V1 equal to the cube of 2R over the cube of R, which is equal to 8. Hence, we have P1 over P2 equal to V2 over V1 equal to 8, or P2 over P1 equal to 1 over 8. The percentage change of air pressure inside the bubble is found by P2 minus P1 over P1 times 100%, which is equal to P2 over P1 minus 1 times 100%. The result is 1 over 8 minus 1 times 100%, which is equal to negative 87.5%, which means the pressure decreased by 87.5%. Question number 3. The temperature of a fixed mass of gas increased by 30% at constant pressure. Find the percentage change of its volume. Since the pressure is constant, we should use the equation V1 over T1 equal to V2 over T2. Therefore, V2 over V1 equal to T2 over T1. Since the temperature is increased by 30%, that means T2 over T1 equal to 1.3. That means V2 over V1 equal to 1.3. The percentage change of its volume again is found by V2 minus V1 over V1 times 100% equal to V2 over V1 minus 1 times 100%, which is equal to 1.3 minus 1 times 100%. The answer is, of course, very obviously equal to 30%. Now, Study question number 4. Before the change, we have equation of state PV equal to nRT, and after the change, we got P pi V pi equal to N pi RT pi. Since the volume of the container is halved, we got V pi over V equal to 1/2. Since the absolute temperature of the gas is increased by 30%, and we got T pi over T equal to 1.3. And since 20% of the gas is expelled from the container, we got N pi over N equal to 0.8. By comparing these two equations, we got P pi V pi over PV equal to N pi RT pi over nRT, and substitute this ratio into the equation. We got P pi over P times 1/2 equal to 0.8 times 1.3. Therefore, P pi equal to 2.08 P. Now, take some time to study question number 5. We got volume 5,000 cm cube, the pressure 2 times 10 to the power 5 Pascal, and the temperature 27 degrees Celsius in Kelvin, which is 27 plus 273 K. Part A, the lump of mole of hydrogen gas N can be found by the equation PV equal to nRT, N equal to PV over RT equal to 2 times 10 to the power 5 times 5,000 times 10 to the power negative 6 meter cube over 8.31 times 27 plus 273. Number of mole of gas equal to 0.40. For part B, the mass of hydrogen gas equal to number of mole N times the molar mass M pi, which is equal to 0.4 times molar mass of hydrogen gas is 2 grams. Therefore, the mass of hydrogen gas is 0.8 grams. Part C, the root mean square speed of the gas is equal to square root 3RT over the molar mass, which is equal to square root 3 times 8.31 times 27 plus 273 over 2 grams, 2 times 10 to the power negative 3, which is equal to 1,933 meters per second. Take some time to read question number 6. We let the final pressure inside the containers to be P pi. By the equation PV equal to nRT, we got number of mole of gas equal to PV over RT. Since the total number of mole of gases is conserved, that means before the tap is open, the number of mole of gas in A is Na and that in B is Nb. The sum of this is Na plus Nb. When the tap is open, the number of mole of gas in A becomes N pi A and the number of mole of gas in B becomes N pi B. The sum of them is N pi A plus N pi B. Since the total number of mole of gas remain the same, we got these two are equal. Therefore, we got PA VA over RTA plus PB VB over RTB equal to PA pi VA over RTA pi plus PB pi VB pi over RTB pi. By substituting the corresponding values into the equation, we got the final pressure of the gas P pi equal to 4 over 3 P. Notice that at equilibrium, the pressure P pi A and the pressure P pi B both are equal at equilibrium. Now study question number 7. This question is similar to that of question number 6, except that the temperature of each container remains the same when the tap is open. That means T pi A equal to T and T pi B equal to 2T. Use the similar method in question number 6 and substitute the corresponding values of V, T, and P pi and P into the equation. We got this equation. Therefore, P pi equal to 2.8 P.